Scientists have identified the direction the Sun is moving as the nose direction, and the opposite direction as the tail direction. The nose direction should have the shortest distance to the heliopause, the boundary between the heliosphere and the local interstellar environment. No probe has taken a good look at the heliosphere from the outside or properly sampled the local interstellar environment. Doing so could provide scientists with more information about the shape of the heliosphere and its interaction with the local interstellar environment beyond the heliosphere. In 1977, NASA launched the Voyager mission, a spacecraft that flew by the outer solar system's Jupiter, Saturn, Uranus, and Neptune. After observing these gas giants, scientists determined that the probes individually crossed the heliopause and entered interstellar space in 2012 and 2018, respectively. Although Voyager 1 and 2 are the only probes with the potential to cross the heliopause, they are far beyond their intended mission lifespans. As their instruments gradually fail or lose power, they can no longer return the necessary data. These spacecraft were designed to study planets, not the interstellar environment. This means they don't have the right instruments to take all the measurements scientists need of the interstellar environment or the heliosphere. This is where a potential interstellar probe mission could come in. A probe designed to fly beyond the heliopause would help scientists understand the heliosphere by observing it from the outside. Since the heliosphere is so vast, it would take decades for a probe to reach the boundary, even with a gravity assist from a massive planet like Jupiter. The Voyager spacecraft will no longer be able to provide data from interstellar space long before an interstellar probe exits the heliosphere. And once launched, depending on its trajectory, it will take around 50 years or more to reach the interstellar environment. This means that the longer NASA waits to launch a probe, the longer scientists will be unable to study the outer heliosphere or the local interstellar environment. NASA is considering developing an interstellar probe. This probe would measure plasmas and magnetic fields in the interstellar environment and image the heliosphere from the outside. NASA has sought input from over 1,000 scientists on a mission concept to prepare for this. The initial report recommended that the probe travel in an orbit about 45 degrees away from the heliosphere's nose direction. This trajectory would follow part of Voyager's path while reaching some new regions of space. This way, scientists can study new regions and revisit some partially known areas. This path would give the probe only a partially angled view of the heliosphere and not see the heliotail, the region scientists know the least about. In the heliotail, scientists predict that the plasma that makes up the heliosphere mixes with the plasma that makes up the interstellar environment. This happens through a process called magnetic reconnection, which allows charged particles from the local interstellar environment to flow into the heliosphere. Like the neutral particles entering from the nose, these particles affect the space environment within the heliosphere. However, in this case, the particles are charged and can interact with the magnetic fields of the Sun and planets. While these interactions occur at the boundaries of the heliosphere far from Earth, they affect the structure of the heliosphere's interior. In a new study published in Frontiers in Astronomy and Space Sciences, my colleagues and I evaluated 6 potential launch directions from nose to tail. Instead of launching close to the nose direction, we found that an orbit cutting through the side of the heliosphere towards the tail direction would give the best perspective on the shape of the heliosphere. This trajectory would provide scientists with a unique opportunity to study an entirely new region of space within the heliosphere. As the probe exits the heliosphere into interstellar space, it will obtain an external view of the heliosphere, giving scientists a more detailed idea of its shape, especially in the contentious tail region.